All right, get ready, because today we are launching headfirst into something truly massive.
Oh, yeah.
A deep dive into NASA's 20-year plan for Mars exploration.
Wow.
Straight from NASA, we've got this incredibly in-depth document that lays out their entire vision for the Red Planet all the way to 2044.
That's a long time.
Are you ready to unpack this roadmap to Mars?
Absolutely.
This isn't just about sending robots, though, is it?
No.
This plan feels like a real turning point
Yeah, it really is.
in how we approach exploring Mars.
It's really exciting.
It feels like we're on the cusp of a new era in space exploration.
Yeah.
Before we get ahead of ourselves, though,
Yeah?
let's zoom out
Okay.
and go back to the basics.
Right.
Why are we so obsessed with Mars in the first place?
Well,
It's not exactly a tropical getaway route.
no, you're right about that.
Not yet, at least.
But Mars has this unique allure to it.
Yeah.
It has the most Earth-like conditions
Hmm.
we've found anywhere in our solar system.
Interesting.
And that makes it the ideal laboratory to try and understand
Okay.
how planets form and evolve.
So it could give us clues about our own planet,
Exactly.
both the past
Uh-huh.
and the future.
The past and the future.
So it's about more than just finding out if there's life out there.
Of course.
Although I have to admit, that's a pretty huge question.
That's right. That's actually the first of NASA's 4 big scientific goals.
Oh, wow. Okay.
With this plan,
Right.
they want to determine if life ever existed
Okay.
on Mars,
Yeah.
or if just maybe it still exists somewhere hidden beneath the surface.
Interesting.
And this question is incredibly complex.
I bet.
What even is life?
Right.
How do we look for evidence of something that might be radically different from life as we know it?
Yeah.
These are the kinds of questions that scientists are grappling with.
It's like trying to solve a puzzle
Yeah,
with some of the pieces missing.
exactly.
What are the other goals driving this 20-year plan?
So the second goal is to unravel the mysteries of the Martian climate.
Uh-huh.
We know that it was once warmer and wetter.
Yeah.
So what caused this dramatic shift to what we see today?
Mhm.
And this ties into the third goal,
Yeah.
understanding the geological history of Mars.
Right.
What can the rocks tell us about its formation
Okay.
and the forces that have shaped it over billions of years?
Wow.
And to answer these questions, we need to get really specific, like analyzing the chemical composition of the rocks,
Yes.
studying the geological formations,
Yeah.
and piecing together the clues hidden in the Martian landscape.
It sounds like planetary detective work.
It really is.
What's the fourth goal?
Well, I think I know this one.
You probably do.
Humans preparing for human exploration.
It's the one that captures everyone's imagination.
Right.
But this isn't just about planting a flag. It's about testing technologies and gathering this crucial data we need
Yeah.
to ensure human survival on Mars.
So thinking about all those challenges.
Intense radiation, the thin atmosphere,
Yeah,
and the need to use the resources that are already present
absolutely.
on Mars.
Right.
In situ resource utilization.
That's the one.
I've heard that term thrown around a lot.
Yeah.
What does it actually mean?
So it's about being resourceful.
Literally?
Literally.
Yeah.
Instead of hauling everything we need from Earth,
Right.
ISRU focuses on using what's already available on Mars.
Yeah.
This could mean extracting water ice from the polar caps,
Okay.
generating breathable air from the Martian atmosphere,
Wow.
or even 3D printing structures using Martian regolith.
So we're talking about a potential paradigm shift here.
We are.
From short visits to actually living on Mars.
Establishing a presence.
This whole idea of Mars exploration, though,
Right.
it didn't just appear overnight.
No, it didn't.
NASA has already sent numerous missions to Mars,
You're absolutely right.
haven't they?
NASA's Mars exploration program has been incredibly successful
Yeah.
over the past 2 decades.
Hmm.
And it's all because of their theme-based approach.
Oh.
Each theme builds upon the discoveries
Yeah.
of the missions before it,
Oh, okay.
which has led to some amazing breakthroughs.
I'm all ears.
All right.
What were these themes, and what have we learned about Mars so far?
Well, think back to the early 2000s,
Okay.
a time when our knowledge of Mars was much more limited.
Yeah.
The first theme was follow the water.
Okay.
Missions like Odyssey and the Mars exploration rovers.
Right.
Spirit and Opportunity
Yeah.
set out to find evidence of water.
The crucial ingredient
Exactly.
for life as we know it.
That's right.
And what did they find?
What?
Was there evidence of this precious H2O?
The findings were groundbreaking.
Really?
Odyssey used its gamma-ray spectrometer
Mm.
to detect vast amounts of water ice.
Oh, wow.
beneath the Martian surface,
Okay.
particularly in the polar regions.
Interesting.
And remember those iconic images from Spirit and Opportunity?
I do, yeah.
They weren't just pretty pictures. They revealed mineral deposits
Yeah.
and geological formations
Uh-huh.
that could only have formed in the presence of liquid water.
So that's really strong evidence.
Isn't
Just
it?
that Mars wasn't always the dry,
Right.
desolate world we see today.
Exactly.
Okay, so we found evidence of water,
Yeah.
but was there ever an environment suitable for life to actually emerge?
That was the focus of the next theme.
Okay.
Explore habitability. A
Hmm.
Curiosity rover,
Yeah.
equipped with an incredible suite of instruments.
It was pretty tricked out.
It was landed in Gale Crater in 2012.
Okay.
It wasn't just looking for water.
No.
It was searching for signs of ancient, habitable environments.
Right.
And what did it find?
What did it find?
Evidence of ancient lakes,
Oh, wow.
flowing rivers,
Right.
and organic molecules,
Wait,
building blocks of life.
hold on. Organic molecules.
Yeah.
So we're talking about potentially habitable environments
Yeah.
on another planet.
On another,
This is getting really exciting.
it definitely is.
But the search didn't stop there.
No, it didn't.
It.
The IMVEN mission,
Okay.
orbiting high above Mars,
Yeah.
studied the planet's upper atmosphere,
Hmm.
trying to understand how it lost its protective magnetic field,
Okay.
and crucially, its water.
Right.
And it painted a picture of a planet that was once much warmer and wetter,
Wow.
potentially capable of supporting life as we know it.
This is fascinating stuff, but I'm guessing we've moved beyond
Yeah.
just looking for past habitabilities.
Yeah.
Haven't we?
Uh-huh.
The burning question is, did life ever actually exist on Mars?
You're right.
Yeah.
That brings us to the current theme, seek signs of life.
Hmm.
This is where the Perseverance rover,
Perseverance, yeah.
which touched down on Mars in 2021,
Oh, okay.
takes center stage.
Perseverance was really cool.
It really is.
I remember that landing.
Yeah.
It was incredible.
It's amazing.
But this mission isn't just roving around taking pictures. It's actively drilling into the Martian surface
That's right.
and collecting rock and soil samples
Yeah,
that might contain biosignatures.
exactly.
Wait, biosignatures?
Yes.
What are those exactly?
So think of them as chemical or physical traces
Okay.
that could only have been produced
Mm-hmm.
by living organisms.
Hmm.
It could be fossilized microbes,
Okay.
specific organic compounds,
Oh.
or even patterns in the rock formations
Oh.
that hint at biological activity.
Interesting.
And this is where the Mars sample return mission comes in.
Okay.
A truly ambitious endeavor to bring those precious samples back to Earth.
Imagine holding a piece of Mars.
I know, right?
In your hand, knowing it might hold the key to answering one of humanity's oldest questions.
It gives me goosebumps just thinking about it.
That would be mind-blowing.
It would.
But what about the fourth goal?
Yeah.
The one about preparing for human exploration?
Right.
Where does that fit into all of this?
That's where things get really interesting. We're moving from the realm of robots and rovers
Yeah.
to the prospect of humans actually setting foot on Mars.
It's a big step.
It is a big step.
Yeah,
And that requires a whole new level of preparation and understanding.
of course.
Every mission we've talked about
Right.
contributes to this goal,
Yeah.
from studying the radiation environment
Yeah.
to testing technologies for resource utilization.
Okay.
But as we prepare for humans,
Yeah.
the focus is expanding beyond just surviving on Mars
So not just surviving,
No.
to thriving.
to actually thriving there.
That's right.
Yeah.
Earlier, we were talking about in situ resource utilization.
Mhm.
Now we're talking about building a sustainable
Yeah.
human presence on Mars.
Absolutely.
This is where things get even more complex, right?
Absolutely.
This is incredible.
It is really incredible.
To make that leap, though, we need to think about more than just the physical challenges.
Right.
We need to consider the psychological impacts
Yeah.
of long-duration spaceflight, the ethical implications of human presence on another planet,
Uh-huh.
and the societal structures we'll need to create to ensure a thriving Martian community.
It's really thinking about the long term.
Yeah, this is a huge undertaking.
It is.
It's not just about rocket science and engineering.
There's so much more than that.
It's about understanding human behavior,
Yes.
ethics, and sociology as well.
Absolutely.
This is truly a multidisciplinary endeavor.
It really is.
But before we get too deep into those aspects,
Okay.
I'm curious about how NASA is planning to make all of this happen,
Yeah.
especially within a realistic budget.
Right.
I mean, this is going to be incredibly expensive.
Well, that's where the idea of a paradigm shift comes in.
Okay.
NASA is embracing a new approach
Uh-huh.
to make Mars exploration more sustainable,
All right.
both financially and technologically.
I'm ready to hear about this new approach.
And that brings us to the core of their 20-year plan.
All right, let's dig in.
This new approach basically boils down to three major changes. First, NASA is shifting away from those mega expensive one-off missions.
Yeah.
And moving towards a model of smaller, more frequent,
Okay.
and yes, more affordable missions to Mars.
That makes sense.
Yeah.
Spread the budget out, get more bang for your buck,
Exactly.
gather more data over time.
Right.
But how do they actually plan to make these missions more affordable? It's not like they can just order spacecraft parts on discount, right?
Not quite, haha.
Okay.
It's about smart design and strategic planning.
Oh, okay.
They're transitioning to smaller, more focused missions,
Yeah.
each tackling a specific scientific question, rather than trying to do everything at once.
Yeah, one step at a time.
Right.
Okay.
They're also investing in shared infrastructure,
Okay.
like communication relays, orbiting Mars, and high-resolution imaging systems that multiple missions can utilize.
It's like building a Martian highway system
Exactly.
in space,
Yeah.
making it easier and cheaper for future missions to get around and send data back home.
That's right.
This is really smart.
Yeah, it is.
Okay.
And here's another key element.
All right.
They're developing standardized spacecraft components that can be reused and upgraded
Okay.
for different missions.
I see.
Think of it like building with Legos.
Okay.
You have this basic set of building blocks
Yeah.
that you can rearrange and adapt for different purposes.
So modular design,
Yeah.
allowing for flexibility and cost savings.
Exactly.
So it's not just about building smaller spacecraft.
Totally.
It's about creating a more sustainable and efficient system overall.
That's the goal.
I've got to ask,
Okay.
where do commercial companies fit into all of this?
That's a good question.
There's been a lot of buzz about public-private partnerships
Yeah.
in space exploration lately.
There has.
Yeah.
And that's actually the second major shift.
Okay.
NASA is recognizing the incredible potential
Yeah.
of partnering with commercial companies
Okay.
to provide services like spacecraft delivery, data transmission, and even some aspects of science operations. It's like tapping into the expertise and innovation
Yeah.
of companies that are already doing amazing things in space.
I see.
Yeah.
It's kind of like how ride-sharing companies have transformed transportation here on Earth.
Right.
NASA can focus on the science while partnering with companies that are experts
These
in
are-
getting things to and from space.
That's a great analogy.
Thanks.
They've already seen success with programs like Commercial Orbital Transportation Services, COTS,
Okay.
and Commercial Lunar Payload Services,
Yeah.
CLPS, which focus on utilizing commercial services for missions to Earth orbit
Okay.
and the Moon.
So they're applying those lessons learned
Yeah.
to Mars exploration.
Exactly.
It frees up NASA
Yeah.
to focus on those big picture science goals.
Right.
I'm also guessing that this partnership approach
Yeah.
helps drive innovation and competition.
Absolutely. By
Like-
bringing in commercial partners,
Yeah.
you inject a healthy dose of competition and a drive to push the boundaries of what's possible. These companies are constantly innovating,
Yeah.
developing new technologies, streamlining processes,
Yeah.
which ultimately benefits everyone
Right.
involved in Mars exploration.
Okay, so we've talked about smaller, more frequent missions, leveraging commercial partnerships,
Right.
and standardized spacecraft components.
Yeah,
This is really starting to paint a picture
I agree.
of a much more dynamic and collaborative approach to space exploration.
Yeah.
But let's not forget the ultimate goal here.
Yeah.
Humans
Yeah.
on Mars.
That's right.
What does this paradigm shift mean for that ambition?
That brings us to the third
Okay.
and perhaps most profound shift as we prepare for human exploration.
Yeah.
The scientific focus is broadening significantly.
Okay.
We're not just talking about geology and climate anymore.
No.
We're talking about human biology,
Okay.
space weather, even agriculture.
Agriculture. Wait a minute, you're talking about farming on Mars?
I am.
Is that even possible?
That's what they're trying to figure out.
What would they grow?
Oh,
Potatoes like in The Martian.
ha. Well, potatoes might be on the menu,
Oh, okay.
but it's certainly more complex than just planting seeds in Martian soil.
I bet.
Scientists are tackling some incredible challenges.
Yeah.
Figuring out how to grow food in Martian soil,
Hmm.
how to protect crops from intense radiation, and how to create a closed-loop ecosystem
Wow.
that can sustain human life.
Oh, this is pretty ambitious.
It is.
Yeah.
Remember, the goal isn't just to send humans to Mars for a short visit.
Right.
It's to establish a sustained presence,
Long term.
right?
Right.
Which requires innovative solutions for long-term survival.
So we're not just sending astronauts. We're
No.
sending farmers.
Well, in a sense, yes.
This is mind-blowing.
It is.
It's like we're building a whole new branch of science.
Right.
Martian agriculture. It all ties back to this idea of cross-disciplinary collaboration.
That's right.
Right.
The science needed to support human life on Mars is incredibly diverse.
I can only imagine.
Need experts in fields ranging from medicine and engineering
Yeah.
to psychology and nutrition.
And I'm sure so many more.
Yeah.
It's incredible.
And what's really exciting is
Yeah.
that as we delve into these new research areas,
Uh-huh.
the knowledge gained can benefit both human exploration
Okay.
and fundamental scientific discovery here on Earth.
It's like this feedback loop of knowledge.
Right.
We learn more about Mars, and that knowledge helps us figure out how to live there,
Uh-huh.
which in turn leads to even more discoveries that
Yeah.
could have applications here on Earth.
Exactly.
It's fascinating.
It is.
But it's not just about sending Americans to Mars, is it?
No,
There's a global interest in exploring the red planet.
you're absolutely right.
Right.
The global interest in Mars exploration has exploded in recent years.
Yeah.
We're seeing space agencies from all over the world collaborating on missions, sharing data,
Mm-hmm.
and working together to make this dream a reality.
This is so cool.
It is.
This international collaboration is essential
Yeah.
for making Mars exploration more affordable and sustainable
Of course.
for everyone involved.
Right.
I can see how that would be crucial.
Yeah.
By pooling resources, sharing expertise,
Yeah.
working together, it reduces the burden on any one nation.
Exactly.
Plus, it fosters a sense of global unity,
I agree.
working towards a common goal that benefits all of humanity.
Uh-huh.
It's like the ultimate team project.
It really is.
This kind of international cooperation isn't just beneficial,
Right.
it's becoming increasingly essential
Yeah.
as we venture further into space.
Absolutely.
The challenges are immense,
They,
and no single nation can tackle them alone.
it's just too big.
Yeah.
Too much.
This deep dive has taken us on quite a journey.
It has.
We've explored the history of Mars exploration, uncovered the secrets revealed by past missions,
Uh-huh.
and witnessed this paradigm shift that's transforming how we approach space exploration.
It really is changing everything.
I can't help but feel like we're on the brink of something truly extraordinary.
It really does feel like we're at a pivotal moment in history,
Yeah.
a time when science fiction starts to become reality.
Right.
What kind of future are we looking at here with this Mars exploration plan?
That's the big question, isn't it?
What possibilities does it unlock?
What could we discover on Mars
Right.
that would change everything?
The possibilities are truly limitless.
Yeah.
As we continue to explore, who knows what incredible discoveries await. We might uncover definitive evidence of past life,
Oh, wow.
fossilized microbes, strange and beautiful rock formations,
Wow.
created by ancient organisms, or even hints of a completely different form of life than we've ever imagined.
Yeah.
Imagine the implications for our understanding of biology and the origins of life itself.
It's mind-boggling to think that life could have emerged on
I know.
another planet,
I know.
even if it's long gone.
Right.
What about the future of technology?
Yeah.
How will reaching for Mars push the boundaries
Right,
of what's possible here on Earth?
We're already seeing incredible innovations in robotics, materials, science, propulsion systems, and more,
Yeah.
all driven by the challenges of space exploration. Just imagine the spin-off technologies that will benefit life here on Earth
Yeah.
as we push the boundaries of what's possible.
What kind of things are we talking about?
Think about advances in energy production and storage,
Okay.
new materials that are stronger and lighter than ever before, and medical breakthroughs inspired by the challenges of keeping humans healthy in extreme environments.
It's amazing to think that the quest to explore Mars
Yeah,
could lead to breakthroughs
exactly.
that improve life for everyone,
Uh-huh.
even those who never leave Earth.
Absolutely.
As we talk about human missions to Mars, though, I can't help but think about the scale of this undertaking.
It's huge.
This is a massive leap for humanity.
It's a leap that will require not just technological prowess,
Okay.
but also global cooperation and a shared sense of purpose.
Yeah.
Venturing further into space will inevitably present challenges
Of course.
that demand creative problem solving
Uh-huh.
and collaboration on a global scale. This endeavor has the potential to unite humanity in a way that few other things can,
I see what you're saying.
as we work together to achieve a common goal
Right.
that transcends national borders and
Yeah.
pushes the limits of human ingenuity.
It's about more than just reaching Mars.
It really
It's
is.
about what we learn about ourselves
Exactly.
along the way.
That's a great way to put it.
This deep dive has taken us on quite a journey.
It really has.
We've explored the ambitious scope of NASA's plan,
Mm-hmm.
uncovered a paradigm shift in how we approach space exploration,
You're right.
and glimpsed the incredible possibilities that lie ahead.
There are so many.
It really does feel like we're at the dawn of a new era of space
I
exploration.
think so, too.
And remember, this is just the beginning.
That's right.
The rapid pace of technological advancement
Yeah.
and the growing global interest in space
Uh-huh.
could lead to unforeseen developments that further shape the future of Mars exploration
Absolutely.
in ways we can't even imagine yet.
It's hard to even fathom.
Who knows what groundbreaking discoveries await us?
Right.
What challenges we'll overcome?
Yeah.
Or what incredible technologies will develop along the way?
It's exciting time.
That's the beauty of exploration, isn't it?
It is.
It's about venturing into the unknown, pushing the boundaries of knowledge,
Yeah.
and daring to dream big.
I love that.
It's about that human drive to explore, to discover, and to reach for the stars.
Beautifully said.
This 20-year plan is a testament to that spirit.
Absolutely.
And I, for one, can't wait to see what the future holds
Me too.
for Mars exploration.
It's going to be incredible.